Today I'm going to talk about... Should we talk about that first? Yeah, let's talk about that first. The letterboard's gone. I mean, it's not gone. I still have it, but it's no longer in the videos. And that's for two reasons, actually. One is it was kind of screwing up my recordings. You know, I forgot to replace the text with something else and then had to redo the recording again. And another thing is that I felt very stressed about having to come up with these awesome one-liners all the time, and I was afraid I was going to disappoint you. So instead of putting this letterboard there and giving me all that stress, what I'm just going to do is to include a few more stupid jokes in the video itself and then hopefully compensate by that. Anyway, this video is not about letterboards, it's about protocols and abstract base classes. They're quite similar in Python, but when you consider them as part of the software design, I think they have actually pretty different uses. So that's what I'd like to show you today, an example where I apply both protocols and abstract base classes and have at the same time very different results in terms of the software design. My channel focuses on explaining intermediate to advanced programming concepts, mostly in Python. But I also like to talk about software design principles and design patterns and basically anything that helps you create a better software design. I've made a lot of mistakes myself in designing software applications in the past. And one of the most important things that has helped me is to basically write down those things. I also want to share what I wrote down with you for free. You can get this at ArjanCodes.com/design guide. It's a 7-step guide that helps you think about your software design, and you can read through it pretty quickly, apply it directly to what you're working on. So get it for free at ArjanCodes.com/design guide. Now let's take a look at today's example. The example I use today to talk about abstract base classes and protocols is an Internet of Things service. There is an IoT folder here that contains a couple of files containing some useful classes and functions. And there's a main file that I use to test a few of these things. So let's first look at the files in here. So we have a device file that contains an abstract base class called device. It has 4 methods: connecting, disconnecting, sending a message to the device, and retrieving a status update. And you see I'm going to use these methods later on in the rest of the program. It also imports a message type from the message file. So this is basically an enum that contains different types of messages: switch on, switch off, change color, play song, open, close, and so on. You can add more to this if you wanted to. And there's also a message class that contains a device ID. So that's the device that the message is intended for. It contains a message type and some data, which is, in this case, a string. Probably you want to do something a bit more complicated if you're really creating a system like this. Then we have a number of devices that inherit from the device abstract base class and therefore implement these methods that it defines: connect, disconnect, send message, and status update. There's a hue light, there's a smart speaker, and there's a piece of curtains, smart curtains. Of course, these are not real objects. I just print out a few things so that we can see how everything fits together. But there are 3 different types of devices that we can use in this system. Then we have a diagnostics function that takes a device as a parameter, connects to a diagnostic server, retrieves a status update from the device, and then sending that to the server. Again, it's not actually doing that, it's just to show how things work. And then we have a service file that contains the actual Internet of Things service. This is basically going to be an object that's responsible for keeping track of which devices are part of our local network and that we can send messages to. So there's a register method and an unregister method. You see it maintains a dictionary of devices via strings, which are the IDs of the device. And when you register a device, it connects the device, it generates an ID, it stores it, and then it returns that ID as well. We have a method for getting a device, so looking for a device given an ID. And finally, we have a method called runProgram. And the program is, in this case, simply a list of messages. And it's just going to send the messages to the devices that these messages are for. And in the main file, I create an Internet of Things service. You see I have all these imports here. I create and register a few devices, so the hue light, the speaker, and the curtains. I create a few programs, so I have a wake up program that is switching on the hue light, the speaker, playing a song, and opening the curtains. And when I go to sleep, well, I want everything to be off and I want the curtains to close. So those are the two programs. And then using the service, I can run these programs and then collect some diagnostics. In this case, I collect some diagnostics of the hue light. When you run this program, you see that it connects first to the devices, then it runs these two programs, the wake up program and the sleep program, and then finally it connects some diagnostics and sends a status update to the server. So this example specifically uses ABCs, as you can see here. We're not using protocols. So there's a few things that are important to know when you use abstract base classes. So one thing is that if you want to inherit from an abstract base class, obviously you need to write that explicitly. You need to import the class. And you see that happening here in the devices. So each of these classes is a subclass of device. Device is imported from the file IoT.device. And that's the case for all three of these. What you also see is that device is used in other places as well. For example, in the diagnostics module, the function that collects the diagnostics needs to know that it gets a device, so it also needs this device class. And for the service, this is actually the same thing. So we're importing the device here because, well, we need to register devices and we need to call the send message method in order to run the program. So that's what this means in terms of dependencies. Everything that relies in some way on the abstract base class, either by implementing it or by using objects that are a subclass of that, need to know about this class, so you need to import it. And if you're using a type checking tool, something like an abstract base class can help you clarify what you need and it's going to point out errors. For example, if I go to the abstract base class and I would comment out this connect method, just like this, then, well, here you're not really going to see a problem because each of these classes just defines a connect method. But if you look at the service now, you see that we're going to get a type error here, that connect is unknown. It doesn't exist, so you can't call it, right? So let's make this abstract method again part of the device, and then obviously you see in the service that the problem is gone. Now, if you go to one of the device subclasses, let's say we are going to comment out this connect method here. So now hue light no longer implements all of the abstract method that it needs to. And well, here obviously we don't get a problem because it's not dependent on the hue light. If you look at the surface, it's also not directly creating the hue light, so there's also no problem here. If you look at the main file, you see that there's a problem here, can't instantiate abstract class hue light. So having type checking switched on helps you find these problems before you actually figure them out when you run the program. So when you run this program, it's going to stop at the point where it's trying to create an instance of hue light. So that's how abstract base classes work. At the moment you create the instance, then it's going to do the type checking and verify that the methods are all there and that there are no abstract methods, because you're not allowed to create an instance of a class that has abstract methods. Protocols were introduced in Python 3.8 as an alternative to abstract base classes, and they work differently from the typing point of view. Abstract base classes rely on so-called nominal typing, and that means if you want a typing relationship to be there, A is of type B, then you need to explicitly write that down in your code. For example, using inheritance. So if you have an abstract base class, you create a subclass of that abstract base class, you inherit from it, and that establishes the relationship. The Python interpreter uses that relationship to determine whether or not the types match. Protocols are quite different. They rely on structural typing. And that means that instead of having to explicitly say that something is of a certain type of a protocol, Python looks at how the structure is of these objects. Do they have the same methods? Do they have the same properties? If so, then it is assumed that the types match. So that means that the usage of protocols is actually also quite different. You don't establish generally inheritance relationships with them. You don't inherit from a protocol class, but a protocol defines the interface that is expected in the part of the program that refers to it. So if you have a function or a method in a class that gets an argument of a particular protocol type, then anything that implements those methods, that has those properties, can be passed as an argument to that function or method. And structural typing, that will actually do the comparison of the structure of the objects, is going to make sure that your program works as you expect it to. This fits very well with Python's runtime type checking system that treats two objects the same if they have the same methods and properties. That's also called duck typing. So now let's change the example to use protocols instead of abstract base classes and see what happens. So I'm going here to the device class, and I'm no longer using an abstract base class, but I'm going to use a protocol. There we go, it has also automatically imported this. And because we're using protocol class, we no longer need these abstract methods here. So I'll remove them. And normally what you also do with protocols is that if you don't provide the implementation, which normally you don't, you write these 3 dots. Let's do that here and here as well. So that's what we have now. I can remove the import here. Our devices, because it's a protocol class, no longer need to directly inherit from the protocol class. The normal way you would do this is use duck typing instead. So I'm just going to remove this inheritance here. There we go. And let's also do that for the smart speaker class and for the curtains class. So that means we can now delete this dependency here. It's no longer needed. In the diagnostics bit, we still need to know that it's going to expect a device so that it can call a status update function. Similarly, in the service, we also still need to import the device class because we're expecting it to have a connect method and a disconnect method and a send message method. So in the main file, nothing changes here. We're still creating exactly the same objects. I can run this now. We're going to get exactly the same result. So the main difference now is when we change this to a protocol, is that we no longer have the import dependency here in the classes that implement that particular protocol. And now the typing system also works differently than what we had with abstract base classes. If I go back to the hue light and I comment out this method again, let's see what happens. So comment out the connect method. And then I go back to the main file. You see there is no problem when we create an instance of the class. Because, well, there is no inheritance relationship. It's simply a class that we can create an instance of, so that's not a problem. What you do see is that you get a type error at the point where we're trying to register the device. Because register device, which is part of the Internet of Things service, expects something that follows the device protocol, that implements the device protocol. And that's, of course, now where the system breaks down, because HueLight no longer has a connect method. And when I try to run this, you'll see that I won't get an error when I try to create the instance, but I'm going to get an error when I try to call the connect method, because that simply doesn't exist in the HueLight class, because it didn't follow the protocol correctly. So this is a key difference between how abstract base classes and protocol classes work. It's the point at which you see the problem occurring. With abstract base classes, that's when you try to create the instance. With protocols, it's when you try to use the instance at a place where it's expecting to implement that particular protocol. A big difference between protocols and ABCs is that protocols are mainly there to define the interface to other parts of the program that use the protocol in some way. So you have a method that has an argument of a type protocol, and that helps define what the method expects. This reduces coupling. For example, the collect diagnostics function doesn't need to know anything about devices that can connect, disconnect, or send messages. It only needs to know that the object has a status update method that it needs to call. Similarly, the Internet of Things service doesn't need to know that devices have a status update method, but it only needs to know that they have a connect, disconnect and send message method, because that's what it's using. So that means that protocols are also a very natural way of limiting the interface and the definition of the interface that you're going to need. What I've done until now is define a device class that contains everything that is part of a device. But with protocols, you don't necessarily have to do that. You can actually split the interface in two and define the part that's useful for diagnostics and define the part that's useful for the Internet of Things service. With abstract base classes, you can in principle also do this, but then you're going to need multiple inheritance. And to me, it feels like a much more natural thing to do with protocols than with abstract base classes. So let's look one more time at the example and see how this works and what the effect is. So let's now split this protocol class into two parts so that each part of our program, the service and the diagnostics part, can use only that which it needs. So what I'm going to do is I'm going to copy this class and I'm going to put it into the service file. There we go. So it's a protocol class still, so I have to import it here. And we also need the message type. And the Internet of Things service only uses connect, disconnect and send message. So status update is actually not needed here. And it doesn't need to know anything about it. So the only thing that the Internet of Things service needs to know is that it has a class device which has connect, disconnect and send message methods. There's an error here. I think I've imported it here. So now, of course, I don't need to do this import anymore. So I'll just remove this and it just has its own device class that it's using in the methods. Now in the main file, this doesn't change anything because that's actually the only thing that a protocol does. It just defines the interface of what you're going to need. And I can do something similar for the diagnostics part. So let's again, I'm going to copy this class and now I'm going to diagnostics and I'm going to put it here. And let's also import a protocol class. There we go. Now the interesting thing is that collecting diagnostics doesn't need to know anything about connecting, disconnecting or sending messages. So let me just remove these things here. And perhaps we can also name this differently. Instead of device, we could name this diagnostics source because it's a source of diagnostics. And let's also change the name here. So now it's a diagnostic source. I could change this name just for completeness. So now here we're just dealing with diagnostic sources and this import is also gone. If you go back to the main file, still this will work just fine because we're really specific about defining, splitting our interface and defining exactly what the different parts of the program needs. And that's, I think, a nice way to think about using protocols. So protocols belong with the thing that defines how it needs the protocol. So this part belongs with diagnostics because that just defines the interface of what it expects as an argument. And similar for the service, this defines what it expects a device to have if you want to use it with the Internet of Things service. And now we can delete this file because, well, we no longer need it because it's not used anymore. Right? So we have our devices, so it simply relies on the message type. We have diagnostics that only uses the protocol import. We have the message classes that are used in different places. And then we have the service that also only relies on the protocol and on these message classes. So the coupling, due to the protocols, the coupling between service and diagnostics has been reduced a lot because we no longer need these imports. The only thing we need to make sure is that our devices implement the right methods. And what's nice is that because diagnostics and devices are in principle different things, we could have a class that only implements, let's say, the diagnostic source protocol. So it only retrieves status data. So it's not something that you connect or disconnect to. It doesn't adhere to the device protocol. And then use that just in the collecting diagnostics part, without it being part of the Internet of Things service. And you can kind of achieve the same thing with abstract base classes, but you'd have to use multiple inheritance, which again, I'm not really that big of a fan. As for interfaces like this, it's fine, but still it introduces a couple of extra imports that are not typically needed. I feel this is a very natural way of thinking about protocols. You simply define the interface of what another part of your system expects. And you pass it an object that adheres to that interface, that implements that protocol. I hope this example shows you that although ABCs and protocols are closely related, there is a kind of conceptual difference that you can exploit. The way I look at it is that abstract base classes conceptually belong to their subclasses. So that's part of a class hierarchy that you're then using in other places of your program. Whereas protocols belong more closely to the places where they're used. I also wouldn't say that abstract base classes are obsolete because of protocols. I think, for example, abstract base class can be a great solution if you have control over who creates the subclasses and you have all that put together in a separate module or something, and you want to keep that nice and tidy together. Because conceptually, protocols belong more at the place where they're used. They might make more sense if you have a huge project with lots of different classes that implement that particular protocol and that you want to use in your application. And maybe in some cases you're not even allowed to change those classes. For example, if they're part of a third-party library that you can't change, well, you could use the protocol mechanism to still decouple your application from that particular third-party library without having to change the library and have it implement some kind of abstract class that you have to define then. So in that sense, I think protocols are really useful when you want to connect different libraries together and still be able to reduce the coupling. A cool thing about protocols is actually that you can define the same protocol multiple times. For example, if you have several modules that you want to be completely independent from each other, but there's still overlap in the kinds of objects that they expect, you could define the same protocol, the same class in multiple files, and then those files you can use everywhere without having to rely on the other file. On the other hand, if you're using protocols that way, if you're not relying on inheritance to define the relationship, then you also lose some of the advantages that inheritance gives you, like being able to create some useful methods already in the superclass that you can then use in all the subclasses. Another thing that inheritance helps you with is if you define the subclass and you explicitly inherit from that abstract base class, then at that point your IDE and the type checking system in your IDE will help you identify any mistakes that you make while you're typing. And with protocols, this isn't possible because there is no nominal relationship between the protocol and the class that implements the methods that the protocol defines. So overall, by using protocols, you do lose some of the advantages that inheritance offers. But it also feels like a very Pythonic way to define the relationships between the different parts of your program. And what I particularly like about it is that it offers a really natural way of splitting up an interface and only define the parts that you're using in that specific area of your code. Doing this has a name, by the way. It's called interface segregation. It's part of the solid design principles proposed by Robert Martin. I talked about that in an earlier video. I've put a link in the top right. And that's also why this is called duck typing. Not because we're ducking something, but because if something walks like a duck and quacks, if something walks like a... No, this is stupid. Okay. I hope you enjoyed this video. If you did, give it a like so the YouTube algorithm spreads the word. Consider subscribing if you want to watch more of my content. Thanks for watching, take care, and see you next time.